Okay, so for 11 and 12, you're going to be estimating the number of radians to the nearest 1/2 radian. So I drew on 11, I drew a dotted ray right here. This is approximately 1 radian. Remember how we measured out the very first time we measured out the unit circle, just the circle, and you measured the radius, and then you measured this out and you marked it with a 1. Well, this is about a radian. And so right here, this is about another one right here. So I would call this one approximately 2 radians. Okay, number 12, you have the angle going in the negative direction. So this is about 3 radians right here. It's 3.14. And then this is about another radian. So 3 radians and 1 more is 4. So this is negative 4 radians. So for number 25, they want you to find 2 coterminal angles, one positive, one negative. I didn't draw the angle, but it's, you could see it in your book, pi over 6. To get another positive angle, what we do is we add 2 pi to our angle and when it's in radians. And to get a negative angle, we subtract 2 pi. So 2 pi plus pi over 6 is 2 1/6 pi. So when you write it, you multiply 2 times 6 is 12, 12 plus 1 is 13, so 13 pi over 6. And then for the negative angle, pi over 6 minus 2 pi, you can get a common denominator. I didn't do that for the plus, but I'll do it for the minus. So it's pi over 6 minus 2 pi. So it's pi over 6 minus 2 over 1 pi, which is pi over 6 minus 12 6 pi. So that gives you negative 11 pi over 6. Okay, so this angle is coterminal with pi over 6, and so is this one. 2 pi over 3 is 2 2/3 pi, because we're adding 2 pi to 2/3. So change it to improper fraction. So you do 2 times 3. You do 2 times 3, that's 6, plus 2, that's 8. So that's 8 pi over 3. So for the negative angle, it's 2 pi over 3 minus 2 pi. Common denominator, because it's over 1, is 3. So this is 2 pi over 3 minus 6 pi over 3. That's still 2 pi. And so that gives me negative 4 pi over 3. So that's this angle, and this angle, and this angle are all coterminal. Okay, for 27, I could subtract, because 9 pi over 4 is 2 1/4 pi. I could subtract 2 pi from 9 pi over 4 and still get a positive angle. So I'm going to go ahead and do that. I'm going to subtract 2 pi, and so I'm going to be left with pi over 4. Okay, and it's coterminal with 9 pi over 4. And so if I subtract another 2 pi, I'll be at pi over 4 minus 2 pi. That's pi over 4 minus 8 pi over 4, which is negative 7 pi over 4. So this angle and this angle and this angle are all coterminal. Now, I could have added 2 pi to 2 1/4 pi. I could have, because like it says in the book, there are many correct answers. But I just chose to give the smallest possible positive one and negative, like the first negative. So letter B, negative 2 pi over 15, it's already negative, and so to get a positive, I could add a 2 pi. So negative 2 pi over 15 plus 2 pi. I'll put over 1, so my common denominator is 15. Negative 2 pi over 15 plus 30 pi over 15, because that's 2 pi. Just using common denominator. So that's, 28 pi over 15. So that's a positive angle. To get a negative angle, negative 2 pi over 15 minus 2 pi. I'm going to put, same thing, negative 2 pi 15th minus 30 pi over 15. So that gives you negative 32 pi over 15. So that's my negative angle. So these two that I circled and this one, those are all coterminal. For 29, it's past 180, right? It goes past the 180 mark. So somewhere between maybe 200 to 220, around there. So that any of those, any angle in this within this range is a good estimate. For number 30, anywhere between, let's say, negative 45 degrees to maybe negative 50 degrees would be good. Okay. Okay, for 39, you're drawing an angle in standard position. So here I have the positive x-axis, so this is my 0 degree. And then negative 30, that means it's going clockwise. So it's approximately right here, going this way. Okay, 150 degrees, here's the angle, the 0. And it's going to be about here, the arrow going that way. So for 41, same thing, we're going to draw angles in standard position. So 405, here's the 0 degrees right here. 405 is 360 plus 45. So here's 360, and then 45 more would be about here. Okay, and then negative 780, again, this is the 0. And it's 360, negative 360 twice, that's 720. So it's going to go 2 times around, so that's negative 360, negative 720, and then 60 more, so about here somewhere. And there's the angle. So 43, we're back to coterminals, but this time it's in degrees. So instead of 2 pi, we're going to be adding and subtracting 360 degrees. So for another positive angle, you add 360 to 52, and you get, 52, you get 412 degrees. For the negative, you do negative 360 and 52. That's going to give you 803, negative 308 degrees. Okay, for negative 36, I'm going to add 36, so 360, I'll just put it here on the side, minus 36, I'm adding 360, so that's 423, so that's 324 degrees, and then negative 360 and negative 36, that's going to be negative 396 degrees. Okay? So negative 300 degrees for 45A, if I add 360, I end up with 60 degrees, so that's coterminal. If I subtract 360, then I end up with negative 660 degrees. For 230, if I add another 360, I'll just put it up here, add another 360, I get 590 degrees. And if I subtract 360, I'll put a negative in front of that one, I get negative 130 degrees. Alright, so 67 through 71 are here on the screen. The only thing, just I want to make a note about this one. These are like pretty much like we did in class, but like this one, notice how it doesn't have minutes. So when you input it into your calculator, you would put negative 125 degree minute second, and then 0 because it has no minutes, so you still have to account for that, and then 36, and then the degree minute seconds. Okay, so you have to make sure you put a 0 for minutes. Okay, so I'm going to go ahead and just subtract these by hand. It says find the difference of the angles, so basically we're subtracting one from the other. So 30 minus 15 is 15, 22 minus 17 is 5, and 51 minus 38 is 13. Okay, so that's the answer for 73. For 75, it's not as straightforward as 73. Notice how I don't have any seconds, so I've got to borrow. Okay, so this is what you do. You borrow a minute from 18, so now I've got 17 minutes. And remember that 1 minute is 60 seconds, so now I have enough. Okay, so now 60 minus 59, that's going to be 1 second. 17 minus 16, that's 1 minute. And then 48 minus 25, that's 23 degrees. And so that's the answer right there. Okay, so here are 77 through 81. Again, just putting them into the calculator. I didn't do these the long way. I just put them straight into the calculator, and this is what you get. So this one doesn't have any degrees. I guess you could put 0 degrees, but I didn't. I just put negative 21 minutes, 18 seconds. So for 93, let me just start it from scratch. For 93, you have the equation S equals R theta. And you have R, you have S, you're looking for theta, right, for this one. So I'm dividing both sides by R. So I'm going to take 8 inches. So for theta, 8 inches divided by 15 inches. So inches cancel, so it's going to be 8/15 radians. So that would be the answer. Remember, radians is unitless, so you could put 8/15. If you want to add radian, that's fine too. So 96 is the same thing. Theta is S over R. So that's gone. 80 goes into 160 2 times. 2 radians. So for 99, the first thing we have to do is convert the angle to radians. So 120 is one of our special angles. So this one you should automatically go to 2 pi over 3 without having to do the pi over 180. Okay, so S equals R theta. So 27 times 2 pi over 3. 3 goes into 27 9 times. 9 times 2 is 18. 18 pi. And the units here is meters. You could punch it into the calculator to get a decimal approximation. So you get 56.55 meters after you put it into a calculator. So S equals R theta. So now we're solving for R because we have S and theta. So I'm going to divide by theta on both sides to leave R by itself. So it's 3 meters divided by 4 pi over 3. So that's 3 times 3 over 4 pi meters. So I've got 9 over 4 pi meters as an exact value. So now I'm going to take a calculator to get the approximate.